A great deal of what we do in Algebra 1 is going to be playing around with this idea of a golden rule. So you have your scale here, and the balance is going to be the equal sign. What we're going to do repeatedly is change one side and do the exact same thing to the other. So for example, we could add 5 to one side of the equation, which would mean we'd have to add 5 to the other so that we would still have an equivalent expression, one that is also true in the same exact way. For example, x plus 9 equals 11 is the same thing as x equals 2, because you can transform this expression into this expression by doing the same thing on both sides. Additionally, one other basic operation we're allowed to do is switch the sides of the expression. So for example, x equals 9 is the same thing as 9 equals x. You can switch sides and you still have an equivalent expression. Also, there's this idea of inverse operations, which are operations that undo each other, such as addition and subtraction. These operations help you to isolate the variable in the equation, which is really the core of what we're doing. We are going to be isolating a specific variable. So for example, we could have the algebraic expression x minus 6 is equal to 11. We want to isolate x, so we need to get rid of everything else that's tacked onto it on the same side, which in this case is negative 6. The inverse operation to subtracting 6 is going to be adding 6. So we add 6 to both sides, which is okay, because we're doing the same exact thing to both sides, in which case we end up with x equals 11 plus 6, so x is equal to 17. This is equivalent to the original, so we know that x is equal to 17. Things can get a little more complicated with double negative signs. For example, j minus negative 5 might equal, let's say, 14. In this case, you'd want to simplify first. Subtracting a negative is the same thing as adding a positive. So now we have j plus 5 is equal to 14. We're trying to isolate j, so we need to get rid of the 5. The inverse operation to addition is subtraction, so we're going to subtract 5 and end up with j equals 14 minus 5, so j is going to equal 9. Here's an example of a word problem where we're going to need to use addition and subtraction to isolate a variable. Several record temperature changes have taken place in Spearfish, South Dakota. On January 22, 1943, the temperature in Spearfish fell from 54 degrees Fahrenheit at 9 a.m. to negative 4 Fahrenheit at 9:27 a.m. By how many degrees did the temperature fall? So how are we going to set this up? Our first step is to create a verbal model. Our verbal model is going to be as follows. The temperature at 9:27 a.m. equals the temperature at 9 a.m. minus the degrees fallen. So now we get to fill in, we can label these variables by saying that degrees fallen is going to be T, and we know that the temperature at 9 a.m. is 54, and we know that the temperature at 9:27 is negative 4. So now we solve for T. We want to isolate it, so we need to get rid of the 54. So we're going to subtract 54 from both sides. So we end up with negative 4 minus 54 equals negative T. And negative 4 minus 54 is going to be negative 58 equals negative T. And now what you can do is, if you know that negative 58 is equal to negative T, T is therefore going to be 58. Here's another question we could do. You are researching United States city parks. You note that Griffith Park is only 418 acres larger than Eagle Creek Park. Write an equation that models the size of Eagle Creek Park. So we need to set up a verbal model. So we know that the size of Griffith Park, right here, has got to be 418 greater than, so added to the size of Eagle Creek Park. So then you could assign variables and say that x, the size of Griffith Park, is equal to the size of Eagle Creek Park plus 418. Now, if you wanted to, you could isolate y by subtracting, in this case y is the size of Eagle Creek Park, subtracting 418 from each side, which would give you x minus 418 is equal to y, which is the size of Eagle Creek Park. You could reverse that saying y is equal to x minus 418. So this doesn't tell you the size of Eagle Creek Park, but it tells you the size of Eagle Creek Park if you knew the size of Griffith Park. I hope you found this video helpful.